This is the 1-7 video part 2. Before we return to your notes, I want you looking at the notes you had from the last video about functions and thinking about this idea. So let's say my graphing calculator was stolen, or something of value. When it was recovered and dusted for prints, you'd say, ooh, okay. So when it was recovered and they dusted for prints, what we found was that one person's name came out, Ms. Holzbach. Ms. Holzbach grabbed my calculator and stole it. Okay, so the input of that particular fingerprint and the output was Ms. Holzbach. Now, each time that that exact same fingerprint was used before, Ms. Holzbach's name came out, and Ms. Holzbach's name came out. And it seemed that this was functioning, an input of one fingerprint, output of Ms. Holzbach every time. So we would say that one input has only one output here. Until they put that fingerprint through a fifth time, exact same fingerprint in their Crime Buster software, and Mr. Bieber came out. We would say at that point that we know that this is not a function any longer, that that one fingerprint going in that had been mapping each time to Ms. Holzbach, and we felt that that was a pretty good functioning relationship, this time output the Bieber, so we would no longer say that that Crime Buster software is functioning, because that same input should have the same output each time. So we want to be able to tell not only from those mappings, we want to be able to tell from a graph, we want to be able to tell easily from a function, that if it's a function or not, without having to do a whole lot of movement of the items. We don't want to have to make a data table out of this if we don't have to. So what we're looking for is at each x value, so there's an x value here because there's a point, there's an x value here because there's a point, there's an x value at 0, there's one at 1, there's one at 2. So there are 5 different ordered pairs and they have each different x values. So at an x of -2, there's only one data point. That's good. When I input -2, positive 2 comes out of this function. When I input -1, I see a solid dot at 2 as well. That's okay. An input of -1 has an output. It's -2. It's okay to repeat the outputs. An input of 0 has 0. I'm just getting the ordered pairs. An input of x is 1 results in this point, which is at -2. And an input of 2 results in its ordered pair, taking the ordered pairs of each point on the graph. And what I'm noticing is that I never have a repeated input, so I never have a chance to declare that this is not a function. Each one of these inputs has its own output, so I'm going to call this one a function. But I don't want to have to write the ordered pairs each time. That would get hard to do, especially if you look at the next 2 graphs. So we want a test. And the test that we're going to use so that you don't have to write out all these ordered pairs and think about your inputs and outputs with as much, so we're going to run a test called the vertical lines test. And here's what it does. If I pass a vertical line, and I'm just going to sketch one in here. If I pass this vertical line from left to right across my graph, as long as it touches my graph only one time, every new vertical line that I pass across there, as long as it only touches my graph in one place, then it's a function. My vertical lines test on this one has failed. What it's telling me is that this particular x value, I could have an output of +1, I could have an output of almost -2. So this is telling me that this is not a function, because at one particular x, there are multiple y values that it matches with. So when I pass that vertical line over the top, if I can anywhere pass a vertical line and touch the graph at 2 points at once, then it's not a function. Okay, and we can give some examples why, but one reason you can put is that it fails the vertical lines test. Here's the other reason you can say it's not a function, is you could give an example. You could say at, and I'm just picking a location, at x is 2, there are 2 outputs. There's more than one output. So at x is 2, I can output a number up around 1.8. I can output a number down around -1.8. So if I were to do a mapping of that, my mapping at 2 would output 1.8, and a mapping at 2 would also output negative 1.8. And we know from our mappings that that's not allowed, that would fail. So the vertical lines test is something you can say is the reason it's not a function, or you can explain something that's happening at a particular data point. This next graph that looks like a tooth. If I pass that vertical line over different places, and I could just take something vertical and kind of scan it across, even though this is heading up steeply on the sides, it's still heading out to the left and right. So never as I go across here with these vertical lines, I never touch it more than once. So then this one is a function. And we could say it passes the vertical lines test. Again, pause video if you need to catch up and write your notes neatly. So the vertical lines test, here's what it is. A relation is a function if there are no vertical lines that intersect, that means cross, its graph at more than one point. I'm going to put vertical lines all over on my graph. Vertical lines are up and down lines. They have to look like this, up and down. So as I pass those along my graph, it is a function if no vertical line intersects at more than one point. Pause here if you need to fill that in, don't rush. I'm going to go back a couple pages, and I'm going to go back to where we left one graph not labeled over here. We're going to take a look and see if we can tell. So this is on the original functions page that you already completed your notes on except this graph, and I'm going to try that vertical lines test. No matter where I pass this vertical line, now you'd say here this graph is still growing and moving out to the right, it's just doing it very slowly. This one passes the vertical lines test, so this one is a function. Each x input has one point that it graphs to on the graph. So we're going to put passes the vertical lines test. So you have two ways to tell. If it's a data table, we're going to be looking for every input having only one output, the box down at the bottom of this page. If we're looking at a graph, we want to be able to tell by that vertical lines test. Now functions are written in a really specific way. So when we write functions, they're often written without the letter y in them, and we don't want that to throw you. But functions are often written with a letter to begin and then a parentheses and this instead of a y equals. What they're telling you is that x is your input variable. That means every time I input, I'm still inputting for x. And when we get stuff out, we're actually going to call it f of x. So that replaces your y value. The f is just the name of the function. Just as we call u by some name to identify u. So we could have a function called g. We could have a function called r. This one happens to be called f. They use it pretty often. So we want to look at some stuff to just get the hang of this. There is a function to convert Celsius to Fahrenheit. Okay? And in that function, whatever it is, our independent or input would be that x. Okay? And in this case, it would be a Celsius temperature. And if you've never seen those, and some of you have lived in places where that's all you use, a Celsius temperature. Our output, our dependent, is that f of x value. It's the value that the function, the equation that we would have up here, would take on for plugging in x. And this is going to give out a Fahrenheit temperature. The ones we typically use in the US, but not all the time. So this notation is going to be asking you what's function's values, and this is all about the notation. This is saying what's the function f worth with an input of 40. Okay, so I'm going to go over to my input side for Celsius. Here's my input of 40, and it's a little hard to read, but an input of 40 degrees Celsius outputs 105 degrees Fahrenheit. In other words, that's what it maps to or belongs to. Each temperature has one equivalent that will come out of this because it's a function. We know every input has one output. So f of 0, they'd like us to go on our scale and have an input of 0. That means we're going to use a Celsius temperature of 0. So I find 0 on here. There's my 0. And for that, I'm going to map over 0 degrees Celsius is freezing. Okay, when you freeze water, you would freeze and make ice cubes at 0 degrees Celsius, and when we input that, we end up getting out a number that you should recognize, 32 degrees Fahrenheit. There should only be one output. We shouldn't have two different freezing temperatures just because we input a different value. So what's it going to look like in algebra? It's going to look like this. They're going to give you a function that actually has an equation to it. This one's a little simpler than the Fahrenheit Celsius one. So if f of x, so here's the equation they want us to use to calculate values from one x value into what it outputs. It says find f of 4. So this would be pronounced f of 4. When someone says it out loud, they'd say f of 4. F of 4 then means to use the f formula, so we have that, 3x minus 4, and input the value of 4 for x, and then calculate, evaluate. So when they ask me to do f of 4, I'm going to write that. I'm going to go up to that formula, and that formula says 3 times your x values, so 3 times the input or x they want me to use, take away 4. So where that x is, that becomes where you're going to input the 4 that they give us. So evaluating this, think order of operations, I need to multiply first, then subtract. So here's what we know. F of 4's value then is 8. All right, on this side now, they've got the same function. F of x is 3x minus 4, that same equation. They're asking us to find f of negative 5. That means use negative 5 for my input. Use negative 5 as my x and tell what's going to happen. So we need to see it substituted first because this says 3 times your x value is what function f does. So 3 times my input, subtract 4. Order of operations, we're looking at negative 15 minus 4. Negative 19 would be what the f of negative 5 value would be. It's a way to ask for an output from a particular equation. F of h then throws people. They'll say, but I'm supposed to use h as my x. Yes, use h as your x. It's asking you to switch variables. It says we used to call the missing number x. Now everywhere you see that missing number in f's formula, I'd like you to use an h. So the formula was 3 times the x value, and instead of x we're using h, subtract 4. So your result then, and the best you can do until we know a value for h, is that that function now becomes the value of 3h minus 4. Seems a little strange. What I want you to do is complete this side, okay? And I'm going to change this side up just a little bit, okay? Instead of g of x plus 3, I'd like you to find g of negative 3, and then add to this, I'd like you to find g of, and this one's going to be the harder one, I'd like you to find g of negative 2m. When you have both of those and the rest of your notes completed, call me over and I'll check it off or help you out if you're stuck.